So, let's look at some more complicated probability problems. First, I got to introduce you to a couple of vocabulary words: dependent versus independent events. So when you name two events, you got to tell whether they're dependent or independent. If I flip a coin and I get heads, does that help you figure out what's going to happen if you flip another coin? No. There's no relationship between flipping one coin and flipping another coin. Those are independent events. They have nothing to do with one another. These two events, completely unrelated. One of them happening does not affect the probability of the other one happening. What color shirt I wear does not affect who's going to win a sporting event. Independent events. Dependent, well, it doesn't necessarily mean that one causes the other, but knowing one at least gives you a clue for the other. For example, it rains and the bus is late. If you know it's raining, this might make it more likely that the bus will be late. The bus could be on time even in the rain. Seen it happen. Bus could be late even if the sun is shining. But if it's raining, it's more likely that the bus will be late. There is a dependency there. How about your gender and your major? Are certain majors more popular among men and others more popular among women? Yes. Being female affects the probability that you choose to major in nursing. There's no obligation there, it's just there's a relationship. So when you're looking at the probability of two events, you have to ask yourself, does one of them have any effect on the other? Is there any relationship? That's dependent versus independent. Any questions? Good. One way to find the probability of multiple events together is to use the multiplication rule. The multiplication rule says probability of A and B is So if two events are independent and you want to find the probability of both of them happening, you just multiply the probability of one happening times the probability of the other one happening. For example, remember my markers? I have 6 of them. I draw a marker, then I flip a coin. What is the probability that I get a green marker and heads? First question, are these independent? Sure, which marker I draw doesn't have any effect on a coin flip. So once again, we got 6 markers, only 1 is green. So, probability, green and heads equals probability of green times probability of heads. What's the probability of green? 1/6, yes. What's the probability that I get a heads when I flip one coin? 1/2. (1/12), or around 0.08 if you prefer. Now, why do we multiply? Why do we multiply when we're looking at multiple events? One way to think about it is when you multiply fractions, they get smaller. And if you want a whole bunch of things to all go your way, it's not likely that you'll get what you want. Okay. I flip a coin 4 times. What is the probability that all 4 flips are tails? You can still use the multiplication rule here. Probability of tails 4 times is find the probability of tails, multiply it together 4 times. So 1/2 multiplied 4 times. What does that give you? 1 out of 16. If I flip a coin 4 times, the probability that I'll get 4 tails is 1/16. Great! This multiplication rule is really easy. You just multiply the probabilities, right? Well, if they are independent. What if they're not independent? Well then, life just got more complicated.